Hi guys, favourite armour penguin again. Today we're going to go a little bit further on the scientific method. So I briefly touched on the scientific method in my last post, and we drew a very high level overview of how the scientific method is more reliable than the statistic method. We saw how observations triggered a hypothesis triggered a prediction triggered a test, and then a theory based off the conclusions of the test. Oh, we're going to go into these steps just a little bit further. Let's start with the original observations that prompt the review. These observations can come from absolutely anyone. There is no central authority in science, so regardless of your education, your job, your social status, your sex, your race, anything like that, you can make an observation and you can put it forward as a hypothesis. These observations may even be an observation that doesn't quite fit the existing model, and that has overshadowed the theory as a whole that needs plugging, but that at the same time doesn't falsify the theory. So, for instance, an example of this would be general relativity suggests that there is much more mass in the universe than we can see. Now, this doesn't falsify relativity, but it does require an extra explanation. So the explanation is that the hypothesis that there is a dark matter that exists, but we can't see, hence why we call it dark. We then come up with our hypothesis, and the hypothesis will explain the observed phenomena. Not only that, but the hypothesis will describe ways to actually verify the hypothesis, and ways to falsify the hypothesis. The hypothesis, therefore, has everything it needs to generate a test, or at least an observation, that will either give a positive result or a negative result. From our hypothesis, we can work on ways to test it. If they cannot be recreated in a laboratory, then we can make observations about the natural world that will either support or falsify our hypothesis. The Michelson-Morley experiment was simple enough. We should see a known phase shift of the light if we are moving through the ether, and we won't if we won't. So this brings us to a null result. And what was seen was neither of the two predictions, and this is a null result. The only thing that a null result can tell you is that the experiment cannot be used to make any conclusion one way or another. So the Michelson-Morley experiment was, well, the result was simply that you cannot use light to measure ether winds. We now know that this is because the ether wind doesn't exist and electromagnetic symbols don't need a medium to travel through. The result certainly doesn't establish that the Earth is stationary. So we can only accept the expected results when performing an experiment. Any anomalous results can only tell us that we are testing the wrong thing. So we either leave the hypothesis as simply that, a hypothesis, or we devise a new experiment to make the observations required to verify or falsify the idea. Speculation on a null result is as useful as listening to, that shady fella down the pub, the one selling the Argentinian racing pigeon. However, if we don't get a null result, and we can repeatedly reproduce that result, we either have a new theory or it's back to the drawing board. So our new theory, having been verified, has to be subject to criticism, which it will be. Once a number of other people can reproduce your results accurately, it becomes what we call peer-reviewed. And peer review is the closest thing the scientific community, having no central authority, can get to be approved. It basically means that the people in that field of science have had a look at the experiments, the results, and the conclusions made with a skeptical mind, because, well, after all, they're using the theory you're replacing, and with any criticisms they can come up with. If you have no answer for these criticisms, then you don't get a pass from your peer review. If you do get past all this and still have your theory, it gets worked into the accepted scientific model, and anyone can repeat your observations. Anyone can map the sky during a solar eclipse to measure the bending of light by massive objects. Imagine exactly what Einstein predicted. The time dilation that GPS satellites suffer from at the speed they are travelling, which is about 7 microseconds a day, is accurately predicted by special relativity. The world is full of these validating observations, And the next big discovery will not only explain these validating observations, but will also explain the next level of accuracy we need to develop the next generation of GPS level technology. So the next time you consider throwing around the term Church of Scientism, just remember that the ideas you are smearing your feces all over have stood up to much more intense criticism and validation than you can manage by claiming that NASA is an anagram of Satan. Alright guys, thanks very much.
Push the tempo, 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 push the tempo.